You've been there! You're processing recycled concrete, production is moving, and suddenly rebar starts causing jams, material flow problems, and costly downtime.
In recycling operations, separating steel efficiently while keeping material moving can make the difference between a profitable day and a frustrating one.
Today on the Lippmann Academy Crushcast, we're looking at a machine built specifically to solve that challenge, the Lippmann 6042M-W magnet conveyor.
Stay with us as we break down the design, the technology, and why this purpose-built recycling conveyor helps operators maximize uptime and material recovery.
Welcome to the Lippmann Academy Crushcast, built for decision makers in high-volume, aggregate, mining, and recycling operations. Nick and Jessica share practical insight for those selecting crushing equipment, managing quarry and plant production, and driving uptime and efficiency across material processing fleets. If your work is about moving rock, maximizing tons per hour, and running safer, more profitable sites, this is your show. This podcast uses AI-generated voice and presentation technologies with human oversight at every stage. All content is developed, reviewed, and approved by Lippmann. The information in these episodes is intended for educational and informational purposes only and does not constitute professional or business advice. Let's get started.
Welcome to the Lippmann Academy Crushcast podcast. I'm your host, Jessica, and I'm joined, as always, by my co-host, Nick.
Great to be here, Jess. We have a seriously fascinating piece of engineering to unpack today.
We absolutely do. I mean, if you're listening to this, you likely already know that recycling concrete, asphalt, and, construction and demolition materials, it's not exactly delicate work.
Definitely not.
Right. I mean, if you've ever stood on a demolition site, you know the environment is just inherently chaotic. It's violently destructive work.
Oh, absolutely.
You're dealing with these massive, unpredictable chunks of concrete, twisted webs of steel rebar, and that abrasive dust that just gets into absolutely everything. Standard equipment just gets chewed up and spit out in those conditions.
Yeah, standard gear doesn't stand a chance.
Exactly. So today we are looking at the product information and specifications for a machine that is, built to thrive in that exact chaos. It's the Lippmann 6042M-W magnet conveyor.
Such a powerhouse.
It really is. So Nick, to kick us off, when you look at the overarching mission of the Lippmann magnet conveyor, what was this machine actually engineered to do differently than, say, just a standard conveyor?
Well, it's an important distinction to make right out of the gate, Jess. A standard conveyor, it just moves material from point A to point B.
Right.
But the overarching mission of the 6042MW is, it's high-volume recycling under extreme duress.
Under extreme duress. I like that.
Yeah. I mean, it is purpose-built to sit right in the crosshairs of a demo site, handle completely uncrushable material, and pull out ferrous metals efficiently without breaking down. The whole philosophy behind its engineering is maximizing uptime in an environment that is, honestly, actively trying to destroy the equipment.
I want to focus on that idea, of an environment actively trying to destroy the equipment. When I'm looking at the product information, the first thing that just jumps right out is the sheer size of this thing.
Oh, it's huge.
It really is. Let's talk about the physical footprint, because you can't survive a loader dropping jagged concrete into your hopper if you don't have the mass to absorb that kinetic energy, right?
Exactly. You need substantial mass to prevent the machine from tipping or buckling under that kind of impact.
Yeah.
So, fully loaded, the 6042MW maxes out at exactly 40,500 pounds.
Wow, 40,500. That is massive. But when you're dealing with a machine that weighs over 40,000 pounds, transportation usually becomes a complete logistical nightmare for the operator.
Yeah, it definitely can be.
Right. You start getting into special permits and heavy haul restrictions. So how is Lippmann balancing that necessary weight with the reality that, you still have to move this thing from site to site?
Well, that's where the strategic weight distribution comes in. It's a substantial piece of equipment, but it's practically perfectly engineered for highway transport.
Oh, really? How so?
Well, they split the total weight. So you have a 9,250 pound maximum on the kingpin and then 31,250 pounds on the axle.
Okay, so it distributes the load across the truck and the trailer axles really evenly.
Precisely. And as to the actual dimensions, it has an overall length of 55 feet 7 inches.
Mm-hmm.
It sits at 9 feet 11 inches wide, and the height is 13 feet 5 inches.
Gotcha.
So when you're hauling it down the highway, it only requires a 10-foot cab clearance. They basically gave it the mass it needs to survive without making it a total nightmare to mobilize.
That's incredibly smart. Okay, so it gets to the site, it's set up, and the work begins. I want to look closely at the impact zone, because this is where the machine's true power comes to life.
Oh, the loading zone.
Right. The loader dumps a massive rebar-filled piece of concrete into the crusher, which discharges directly onto the 6042M-W's loading zone. How does the loading zone keep from getting completely pulverized day after day?
Well, it survives because of the 48-inch by 78-inch fully enclosed pan feeder. That's the frontline defense right there.
Okay.
Its entire job is to take that violent impact and then feed the material smoothly onto the belt. And to do that, it utilizes dual vibe units running at a maximum of 1,200 RPMs. And that's powered by a 2.5 horsepower motor.
Wait, why dual vibe units? Is that just for extra power, or is there an actual mechanical reason you need two separate units vibrating that pan?
It's entirely about uniformity, Jess.
Yeah.
If you just have one central vibratory unit on a pan that wide, you end up with different frequencies at the edges of the pan versus the center.
Oh, and that caused problems.
Huge problems. It creates dead zones.
Yeah.
And if you have dead zones, sticky material or jagged rocks build up. They create blockages. And suddenly your multi-million-dollar operation is totally choked out and sitting at a standstill.
Oh, wow. Yeah, that makes sense.
Right. So dual vibe units ensure the material spreads uniformly across the entire 48-inch width of the pan. It just keeps everything flowing perfectly.
Okay. I have to push back a little here, Nick. Spreading material uniformly is, well, it's great in theory, but we're still talking about raw metal-on-metal impact.
Oh, for sure.
Right, because when you drop heavy, jagged concrete onto a steel pan feeder, you get metal fatigue. And usually, that means constant welding repairs, taking the machine offline, getting hot work permits, and then just sitting around waiting for the steel to cool before you can run again.
Yeah, the maintenance trap.
Exactly. How does this machine avoid that maintenance trap?
It's a critical problem for operators, absolutely.
Yeah.
And the solution here is really elegant. Instead of traditional weld-in liners, Lippmann uses bolt-in replaceable liners.
Oh, bolt-in.
Yeah. If section gets too worn down, you just unbolt it and drop a new one in. No welders required at all. But, the real genius of the engineering is that these liners are rubber mounted.
Wait, meaning there's a layer of rubber actually sitting between the replaceable steel liner and the structural frame of the feeder.
Precisely. The rubber actively absorbs the kinetic shock of those impacts. Think of it like the cartilage in your knees.
Oh, that's a good analogy.
Right. Instead of bone grinding on bone, or in this case steel slamming into rigid steel, the rubber compresses and dissipates the energy. It drastically reduces the structural stress on the overall feeder.
That is a brilliant way to prevent microfractures in the chassis.
It really is. And they took that shock absorption philosophy a step further with how the pan itself is mounted.
How so?
Well, a lot of older designs use hanging mounts for the vibrating pan, which tend to sway, wear unevenly, and eventually snap under heavy loads.
Yeah.
The 6042M-W uses spring mounts.
Okay, so they sit underneath.
Exactly. They sit underneath the pan. They are mechanically simpler, incredibly robust, and they provide a much, much longer operational life. And just to ensure things keep moving, there is a deliberate open flow design in the transition space between the crusher and the pan feeder.
What does that open flow design actually prevent, practically speaking?
Rebar bridging. Yeah, when you have long, twisted pieces of steel rebar coming out of a crusher, they love to get tangled up and bridge across narrow gaps, creating a massive jam. By keeping that transition space wide open, the long pieces just flow right through without getting caught.
That's so smart. So the material survives the drop, it flows smoothly out of the pan feeder, and now it hits the conveyor. We are talking about moving an incredible amount of weight here.
A staggering amount, yeah.
I mean, the specifications highlight a massive 60-inch wide conveyor belt that is 5 solid feet of heavy, jagged, wet aggregate moving continuously.
A lot of rock.
Right. But looking at the power specs, it relies on a 25 horsepower electric drive. Nick, I have to be honest, 25 horsepower sounds a bit, underpowered to muscle 40,000 pounds of rock up a steep incline.
On paper, I totally understand why you'd question it, Jess. But it's not just about the raw horsepower. It's entirely about how that rotational force is delivered to the head pulley.
Okay, explain that.
The machine features an oversized electric drive motor, but it's paired directly with a torque arm reducer.
Let's break that down for the listener. What is the actual physical mechanism of a torque arm reducer, and why is it better than just a standard direct drive?
Sure. So, in a standard direct drive setup, when a massive slab of concrete hits the belt, it causes a sudden spike in resistance, right? Mm-hmm. That shock wave travels straight down the shaft and directly into the electric motor. It can stall the motor overheat it, or even physically snap the internal components.
Wow.
Exactly. A torque arm reducer is essentially a specialized gearbox designed specifically for high shock load applications. It physically absorbs those sudden torque spikes so the motor doesn't have to.
Oh, I get it. So the reducer takes the beating, allowing the motor to just sort of hum along at a constant speed.
Exactly. It protects the heart of the system. It also reduces the overall number of drive components, and, the housing is completely sealed.
Which keeps the dust out.
Yes. The internal gears are protected from the incredibly abrasive dust of a demo site. So because the power deliveries is so highly optimized, that 25 horsepower motor easily keeps the belt moving at 300 feet per minute.
Wow, 300 feet per minute. That's fast.
And it reaches a maximum discharge height of 140 inches. And it's also worth noting that it uses standard off-the-shelf parts.
Oh, that's huge for uptime.
Totally. If something does wear out, you're just going down to a local supplier to get a replacement, not waiting 6 weeks for some proprietary part to ship from overseas.
Which means the machine actually stays running, but, keeping the belt moving is really only half the battle. Keeping it clean is the other half.
Oh, yeah, the mud.
Right. When you run wet mud, sticky clay, and fine debris on a conveyor, it kind of reminds me of trying to run a hairbrush through incredibly tangled sticky hair.
That is a great visual.
It's true. Eventually, the brush gets completely packed with gunk and just glides over the top, doing absolutely nothing. So how does this massive 60-inch belt avoid getting packed with mud and tracking sideways?
That hairbrush analogy is spot on, Jess.
Yeah.
Because a standard flat tail pulley, which is the drum at the bottom end of the conveyor, it operates exactly like that. The belt wraps tightly around a solid steel drum. If there is clay on the underside of the belt, it gets smashed against the solid drum, packing tighter and tighter until it forms a hard lump. That lump stretches the belt, makes it track off center, and eventually it just rips the rubber.
Which is like catastrophic failure.
Exactly.
Yeah.
The 6042M-W solves this completely by using a chevron tail pulley.
A chevron tail pulley. Okay, how does the geometry of that prevent the clay from packing?
Instead of a solid flat drum, picture a cylinder made of angled wing-like segments forming a V-shape or, a chevron.
Okay, I'm picturing it.
As the belt wraps tightly around these wings, the pressure actually forces any loose, sticky mud to squeeze out between the open gaps in the segments.
Oh.
Yeah, the mud falls safely to the ground instead of getting trapped against the metal. The pulley literally cleans itself as it rotates.
That makes perfect sense. The mud actually has an escape route.
Precisely. And Lippmann pairs that self-cleaning pulley with full-length skirting along the entire length of the conveyor. That keeps the chaotic material securely on top of the belt so it doesn't spill over the sides and foul up the rollers.
And what about at the top?
Right at the top, where the material discharges, there is a dedicated belt scraper pressing against the rubber to just peel off any stubborn, sticky clay, which greatly reduces carryback down the underside of the belt.
It really highlights how the smallest engineering details prevent the most expensive breakdowns.
It does.
Let's shift gears to what is arguably the most critical job of this machine. I mean, if you are recycling construction demolition material, your primary goal is separation.
Always.
You absolutely have to get the scrap iron and steel rebar out of the clean aggregate. So how does the electromagnet on this unit manage to pull heavy steel out of a fast-moving pile of rocks?
It does it by using gravity and momentum to its advantage, Jess. The machine utilizes a highly powerful self-cleaning electromagnet, but the real secret to its efficiency is its physical location.
Okay.
It is mounted in line.
As opposed to hanging over the middle of the belt.
Exactly. On other machines, you will often see a cross-belt magnet suspended directly over the flat part of the conveyor.
Right, I've seen that.
Well, that magnet is fighting a massive disadvantage. It has to use sheer magnetic force to pull a heavy piece of steel straight up, literally fighting gravity and pulling it through a heavy layer of rocks that are physically sitting on top of it.
That seems incredibly inefficient.
It requires massive energy and it misses things. By mounting the magnet in line right at the head section, where the belt curves downward to drop the material, the magnet waits for the exact moment the rock and the steel naturally launch off the end of the belt into the air.
Oh, I see. So it is kind of like a baseball center fielder perfectly timing a catch the split second the ball leaves the bat.
That's a perfect way to describe it.
The material is in free fall. It is essentially weightless for a fraction of a second, and the magnet snatches the steel right out of the air.
That is the exact physics of it. Because the material is airborne and spreading apart, the heavy rock isn't pinning the rebar down anymore. The magnet doesn't have to fight gravity at all. It just elegantly pulls the iron horizontally away from the falling aggregate.
Well, wait, if it is snatching jagged, heavy steel out of the air at high speed, isn't that flying shrapnel going to shred the magnet's own conveyor belt?
It absolutely would if it were a standard rubber belt.
Well,
But the electromagnet's belt is steel-clad.
oh, nice.
Yeah, it is heavily armored to resist punctures from sharp rebar. And if a plate does somehow take a massive hit and bend, the plates are individual. You can easily replace a single piece of steel right there in the field without having to string an entirely new belt.
So the magnet catches the rebar midair. Where does it throw it?
It utilizes a specifically angled go-no-go chute. It is designed to aggressively push the separated ferrous material far off to the side, dropping it into a dedicated bin that is completely isolated from your clean aggregate pile.
That's incredibly clean separation.
It is. And, if an operator takes on a job that doesn't have tramp iron, say they're just moving pure aggregate, the entire magnet and rectifier assembly can actually be unbolted and removed to save weight and power.
Talk about modular versatility.
We do. That modular versatility is one of the things that makes Lippmann global leaders in crushers and conveyors.
Okay, let's take a quick breather here. So far in the product information, we've covered the massive footprint needed to absorb heavy impacts, the incredibly smart rubber-mounted pan feeder that prevents structural fatigue, the chevron tail pulley that sheds sticky mud, and that ingenious inline magnet that catches rebar in midair.
A lot of great tech.
It really is. But as impressive as those specifications are, how does this machine actually perform out in the mud and the ruts of a real job site compared to the competition? How easy is it to set up and, how easily can you move it? We are going to dive into the comparative benefits right after this quick break.
Stick around.
Tramp iron is the biggest killer of blow bars. Even after your 6042 magnet removes loose steel from the feed, metal remains locked inside recycled concrete and heads straight for your impactor. That's why alloy selection matters. And Lippmann blow bars are built to match the feed, not just fill the rotor. As the OEM parts provider for Lippmann crushers, MPP Aftermarket supplies blow bars engineered for the toughest recycling applications. Whether you need the impact resistance of manganese and martensitic steel or the extended wear life of martensitic ceramic, the right metallurgy helps prevent costly failures and maximize uptime. A will-fit blow bar may look the same, but you can't see the metallurgy. In contaminated feed, that's what makes the difference. More uptime, longer wear life, lower cost per ton. Ask your local dealer about genuine Lippmann OEM blow bars.
Welcome back to the Lippmann Academy Crushcast. Now, let's rejoin Nick and Jessica as they continue the conversation.
Welcome back to the Lippmann Academy Crushcast featuring the 6042M-W. Nick, before the break, we mapped out the core mechanics of how this machine moves and cleans material. But I want to pivot to the realities of the job site.
The fun stuff.
Exactly. We established earlier that this machine weighs over 40,000 pounds. Demolition sites are not paved parking lots. They are deeply rutted, muddy, totally chaotic landscapes.
Understatement of the year.
Right. So when you are towing 40,000 pounds of steel across that kind of terrain, how does the suspension keep the machine from just tearing itself apart or tipping over?
It's a really critical issue. If you look at other competing rock crusher equipment manufacturers, many of them try to cut costs by using a single hutch suspension design on the axles.
What actually happens when a single hutch suspension hits a deep rut?
The entire machine suffers. In a single hutch setup, the axles are rigidly tied to the frame. If one wheel drops into a 2-foot pothole, the entire 55-foot chassis violently tilts down into that hole.
Oh, wow.
Yeah, that puts catastrophic twisting stress on the steel frame, and it creates a serious tipping hazard. Lippmann entirely avoids this by utilizing a tandem walking beam suspension.
Okay, so how does a walking beam physically interact with the ground differently?
Think of the walking beam as a central articulating pivot point, located directly between the front and rear wheels on the axle.
Okay, on my feet.
If the front wheel hits a massive rock, the beam simply pivots upward. The wheel travels up and over the rock, but the main chassis of the machine stays perfectly level.
Oh, that's amazing.
Right, it literally walks over the terrain. This completely isolates the frame from the shock of the uneven ground, prevents any single tire from taking the entire 40,000-pound load, and, provides vastly superior stability compared to other machines.
That fundamentally changes how safely you can maneuver the machine on site.
Absolutely.
Now, what about the setup process? In the past, getting a massive conveyor spread set up required calling in a separate crew, hooking up hydraulic lines to a front-end loader, or sometimes even bringing in a crane. What did the setup look like for the 6042M-W?
Well, Lippmann engineered it so you basically don't need any external heavy equipment to set it up.
None at all.
None. It utilizes an entirely self-contained hydraulic system. There's an onboard electric start gas power unit sitting securely in a lockable steel cabinet, right alongside a 20-gallon hydraulic tank.
So it generates its own hydraulic pressure completely independently. You just turn the key.
Exactly. You don't need to tie up your loader or your excavator. Once you turn it on, hydraulic cylinders safely and smoothly raise and lower the head section of the massive conveyor.
And it locks in place.
Yep, it features heavy-duty integrated locking pins, so once you find your exact operating angle, you lock it in solid. Additionally, it features hydraulic landing legs.
Oh, that's convenient.
Extremely. When you need to pack up and move, you just hit a lever, the hydraulic legs raise the heavy tail section off the ground, and your transport truck can easily back right under the kingpin. And I think it is vital to point out that this level of fully independent hydraulic lift running gear is completely absent on many other machines.
Which brings me to what I think is honestly the most impressive competitive advantage in these specifications.
I think I know what you're going to say.
The secret weapon of mobility. Let's say you have the whole plant set up and running, but halfway through the day, the operator realizes the material flow is slightly off, and they need to move the conveyor backwards, just like 3 or 4 feet. On a traditional site, do they have to go find a tow vehicle, hook it all up, and drag it those few feet?
Historically, yes, they do. And it is a massive drain on productivity. You have to stop crushing, pull a loader away from feeding the hopper, hook up heavy chains, drag the conveyor, unhook it, and set it back up.
Just for 3 feet.
Exactly. You can waste an hour just to move the machine 3 feet. This is where the 6042M-W completely distances itself from other magnet conveyors. It features an available hydraulic drive wheel option.
Wait, it has a powered wheel. It can physically drive itself?
It actually can. The hydraulic drive wheel is a self-contained assembly that drops directly into the tow hook connection on the tail section.
Oh, wow.
Yeah, it uses quick connect hoses that plumb right into that onboard gas power unit we just discussed earlier. Once it's plugged in, the operator stands at a set of hydraulic levers. They can raise the tail, lower the tail, steer the wheel left or right, and drive the entire 55-foot, 40,000-pound conveyor forward and backward completely standalone.
That is incredible. So one operator, entirely by themselves, can reposition the machine perfectly under the crusher in, 2 minutes and immediately get back to production?
Yes, it's done safely with total precision without tying up a single piece of support equipment. And again, if you look across the industry, other magnet conveyors on the market simply do not offer this powered drive wheel option.
It's a huge advantage.
It really is. Nor do they offer that heavily armored, fully enclosed pan feeder. Those two features alone eliminate thousands of dollars in wasted downtime and labor costs.
Now, Nick, with all these complex hydraulic features, the standalone driving, the vibrating pans, and the electromagnet, how does an operator actually manage all of this safely? Often, when machinery gets this advanced, the controls become an absolute nightmare to figure out.
Yeah, Lippmann understands that the operator's likely wearing thick leatherwork gloves and dealing with glaring sunlight and dust, so they kept it incredibly intuitive.
Okay, good.
The electrical controls are centralized in a highly durable, user-friendly NEMA control panel. There are no complicated, delicate touchscreen submenus. It uses simple, weather-resistant push-button controls.
Reliable tactile feedback. I love that.
Absolutely. And they built in safety and transport accessories that actually reflect real-world site conditions.
Like what?
Well, for example, there's an integrated light bar for the brakes and turn signals. But instead of mounting it where falling debris will inevitably smash it, it's tucked away completely out of the material flow. It also features heavy-duty mud flap bars that are integrated to stay securely in place during both aggressive operation and highway transport.
It really paints a picture of a machine designed by people who have actually spent time sweating on a demo site.
100%.
From the shock-absorbing pan feeder to the self-cleaning chevron pulley to the inline magnet that catches rebar in the air and that brilliant standalone hydraulic drive wheel, every major headache an operator faces has a specific mechanical solution built right in.
It's engineered to work as hard as they do.
Nick, as we wrap up our analysis of the 6042M-W magnet conveyor, what is the final thought you want to leave the listener with today? Like, when they're looking at all this heavy iron, what is the broader implication for the industry?
I think the most important thing for operators to consider is what happens next in the recycling industry, Jess. We are rapidly approaching an era where downstream sorting is going to be handled by highly sensitive optical scanners, AI-driven robotics, and automated sensor systems.
Right.
But those high-tech systems are entirely useless if the primary mechanical separation isn't flawless.
Oh, that makes sense. Garbage in, garbage out.
Exactly. Machines like the 6042M-W are the critical bridge to that future. If you can't reliably survive the brute force of the initial impact, and if you can't cleanly pull the heavy steel out of the rock right at the source, your high-tech downstream tech will just constantly jam and fail.
Right.
The operators who invest in flawlessly engineered high-uptime primary separation today are the ones who will successfully integrate the fully automated technologies of tomorrow.
You cannot build a high-tech future on a foundation that constantly breaks down in the mud. That is incredibly insightful. Nick, thank you so much for walking us through these specifications and breaking down the complex engineering so clearly today.
My pleasure, Jess. Always a great time diving into the mechanics with you.
And to you, the listener, thank you for joining us on this exploration of heavy-duty recycling mechanics. If you're ready to see how the Lippmann 6042M-W magnet conveyor can elevate the efficiency and profitability of your operation, your next step is very simple.
Just reach out.
Exactly. Contact a dealer from our network, which you can easily find directly on the website at lippmanncrushers.com. You can also explore the exact product specs and all the figures we discussed today by clicking the link provided in the show notes.
Definitely check those out.
And finally, please make sure to download, subscribe so you never miss an upcoming discussion, and share the Lippmann Academy Crushcast podcast with your colleagues out in the field. Until next time, keep crushing it.
Thanks for joining us on the Lippmann Academy Crushcast with Nick and Jessica. To explore more insights, catch new episodes, or learn how Lippmann is helping customers run smarter, safer, and more productive operations, visit lippmanncrushers.com and follow Lippmann Academy online. We appreciate you listening. See you next time.